Okay, so in the previous video, I made this LCD hood by using Autodesk Inventor because I have tried with the FreeCAD and it didn't work in the loft function. But I found out later that it's actually the implementation of this loft function in FreeCAD is different from other CAD software. Now I can create the same LCD hood by using a FreeCAD. So in this video, I'm going to do demonstration, step-by-step guide, starting from importing the point cloud and creating this LCD hood for 3D printing in the FreeCAD version. So click on new, click on this icon for create a body. I'm now in the part design mode, and then I'm going to import the point cloud. I have two point clouds, the body of the scanner and the cap. This one has already been placed into origin point and aligned to the XY plane. So you can look into my previous video for the detail. Click on the point cloud to change the color. I choose a bright yellow color and reduce the point size to 1. And then I'm going to turn on the origin point. So we have 3 planes here. It's in the origin point. Next, I'm going to move the XZ plane onto this edge on the LCD screen. I do that by clicking on this icon, create a datum plane, and then I click on the XZ plane, and then I'm going to move it along the Z-axis, which is perpendicular to this yellow plane. So I'm going to put in a number so that it will be in this location, this joint. See this joint? I'm gonna put like let's try 80. 80 too much, so I'm gonna move it using the arrow until the plane is closer to this point. Now need to be like 51.5. Okay, 51.5 seems to be the location of the plane. See the line here, that will be the joint between the LCD screen and the body of the scanner. I click on OK. Now you have a plane here that we can create a sketch in this section of the plane. Let me save it. Okay, next I'm going to click on the plane, click on create a new sketch of the origin point. Click on this line, horizontal line, second line, horizontal line. Okay, here's a third line. Okay, so everything look alright. So I will lock all the lines in place. Now it's locked. It's turned into green color. It means that it's locked. And then I will create an arc with 3 points. 1, 2, and 3. And then I'm going to make it tangent. Okay, one more here. 1, 2, and 3. Make it tangent. So now the line is tangent. Let me give the dimension here, 80. Okay, now let's put it back to the constraint. Next I'm going to trim it using this command. Okay, now it's trim. I'm going to trim this one. Remove the line. I'll create a mirror axis here. And then I'm going to select the lines for mirror. And then I'm going to click in this icon, select on the axis. Now it's mirror into this side. It looks like that it's too far to the left. So let me move the point clouds placement. I think it's too far to the right. Let's try 0.3. Yeah, 0.3 look okay. Let me click here, go back to the sketch again, and I will remove the mirror line. Let me arrange this, move this up here. Okay, these two lines is not connect. Okay, the connected point will turn into orange color. So if it's white color like this, it means that it's not connect. So you need to connect it. Okay, now it's connect. It's returned to orange color. Let's apply the tangent Okay, now tangent is applied. All the line is connected. Okay, let's do it one more time. Select this line, mirror it. Okay, now it's perfectly mirrored. Okay, I will remove these two lines and I make it just one single line, right? So this will be a boundary line. I will offset this line for 0.2 millimeter. So I select all the lines here and then I'm gonna click here to offset it to 0.2 millimeter. Okay, so I'm going to offset this one to 0.2 millimeter. So I have some clearance when it's fit into the body of the scanner. I do this by dragging all the lines here. Click on this icon and the mode. I will choose intersection and I will type in 0.2 for the offset value. So it will offset both inside and outside of the lines. So what I have to do is just delete the inner line. So there's extra work that you have to do because I don't have to do this when I use the Inventor. And you see this line, this two line is not connect because if it connect, it will turn into orange color. So you need to lock one of the line and this line, and then you constrain it. Okay, I'm gonna delete this line and then I'm going to draw a new line. Okay, so now it's connect. If the line is connect, it shows in the a red point. So now we have all the line connected. Okay, let's delete the original lines. If you don't want it to move, just lock it. Now I lock all the lines. Okay, next I'm going to offset for the thickness of the shell. I do this by selecting all of the lines, click on offset and click on intersection. I choose 2 millimeter for the thickness. Okay, all done. As you can see, the new offset line is joined properly. So that's a good sign. I'm going to delete the inner side of the line. And then I'm going to close the profiles. Close the profiles. And the line is not joined, so I do it again. If the line is not joined, it's gonna give you white color. If it's joined, it will give you orange color. So now you are done with the first sketch. Okay, let's test if this sketch has a proper close loop. I do this by clicking on the sketch and click on the path command. So now I can extrude it, which means that it has a closed loop. Alright, so the first sketch is done. Let's create a second profile for lofting. Let me turn on the previous plane. So I'm going to create a new plane and I'm going to move this plane closer to the camera bump on the side. Click on this first and click on this plane and click on -8. Okay, so I'm going to create a plane that is offset to the right 8 millimeter, so which is just enough for the camera bump. Click on OK. So the new plane is created, which is this one. Next, I'm going to create a new sketch. Click on this plane, create a sketch. I'm going to project the geometry from the first sketch, which is this one, and create external reference. Okay, so it's quite difficult to click sometime. This is the projected line. You probably can see it. I'm going to trace a new profiles. First line, second line, and the third line. Okay, the third line, I move it a bit here. Okay, so the third line should be end here, so it has the same height as the first sketch. Let me trim it. Okay, now I trim it. Right, after that I'm going to lock all of the lines 1, 2 and 3. These 3 lines lock. It should change color into the green color. And then I'm going to make 3-point arc, put it into tangent. Okay, now it's tangent. Another 3-point arc. Okay, put it into a tangent. Okay, now it's right. Next step, I will trim it using this one. Trim, 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 and trim. Okay, let me remove this. Okay, let's lock everything so we don't have to worry about accidentally move it. Next, I'm going to select all these lines and mirror it. Okay, let me select everything. They have this function that you can delete the original offset. So 0.2, right? So you only need to delete the line that is inside. Let's close the profiles. You close it. It should give you orange color like this. Orange point. Okay, orange point. Now we have complete. Alright, the reason that I cannot love these two profiles together, if you notice that the two sketch has to contain the same amount of vertices. I mean, you can love rectangle to a rectangle, but you cannot love a hexagonal to the octagonal because it has different vertices. The number of vertices has to be the same. If you look closely, I don't know how this happened, but the second sketch has more lines, see here, but the first sketch has only one line on the top. I'm going to delete these two lines and create a new line. One easy way to check, you're gonna go to the sketch and see here, this sketch contains 20 lines, right? So your second sketch has to contain 20 lines. So if your second sketch and first sketch has different number of lines, it will not be able to love. So please keep that in mind. Each line can have different radius, different length, different orientation, but it needs to have the same amount of lines to create a loft. So this time it will work, I can guarantee. See here, just one click and it's done. Click on OK. Now you have a loft. Okay, next I'm going to import the cap that I made with the cloud compare. So here's the cap. Let's change the color and size of the point clouds. I need to create a datum plane. Click on OK. Click on the plane. Create a sketch. Let me turn off the plane. Okay, and you can see that there's a fade line, and I'm going to turn on the cap. So the cap is it's not in the center. I'm going to create a 3-point circle. 1, 2, and 3. I'm gonna click on here and here. So it's 0.91 along the y-axis to the right, 0.91, and it's 0.98 along the x-axis going up. So I'm going to change the cap position. Click on close, click on cap, right click, placement. So it's 0.91 and minus 0.98. Okay, now the cap should be in the center. Let's go back to the sketch, remove the circle, redraw the circle again, 1, 2, and 3. Now it's very close. See here, this 2 point is very close now. So the cap is now in the center. Now I'm going to lock this circle because it's in the center, and I'm going to create a circle for 50 millimeter. So it's going to be larger than the cap. And then I'm going to project the geometry from this line, and I'm going to draw the line from here to tangent with this line, the line from here tangent with this line, so it's tangent. And then I'm going to project this line. Okay, going to draw a line from here to here and from here to here. Okay, one more line. Okay, looks like it's connect to each other. Let me trim this line of the circle. Let me draw an arc. 1, 2, and 3. And I'm going to give it a dimension for 9 millimeter. Do the same for this. 9 millimeter. Okay, about this. I'm going to trim this one. So now I will close the sketch. And then let me click on this here, pad. I'm going to pad it down for 2 millimeter. Click on OK. Now we have our second extrusion. Okay, let's move the cap up for 2 millimeter so it will be more realistic. Okay, next I'm going to create a stiffener for 3 millimeter. I click on this plane, and then I'm going to create a sketch, and then I'm going to project the lines. 1, 2, 3, 4, 5. So I project 5 lines. Trace the lines. Click on lines. 1, 2, it's not connect. 2, 3, 4, 5. Okay, we have 5 lines. So I will mirror this line. 1, 2, 3. These 3 lines. Mirror to the other side. And then I'm going to connect this line. Okay, next I'm going to offset all the lines. Click on offset. Click on intersection. Offset it for minus 2 millimeter. Next I'm going to close it. And then I'm going to extrude it for 3 millimeter. Click on OK. But I don't want this part to be extruded because I want to print it in this direction and I don't want to have a support. So I will go back to the sketch from this point to this point, from this point to this point. Okay, then I will close the sketch. Pad 3 millimeter. Save it. Okay, next let's drill a hole for the antenna thread. Click on this plane, click on sketch, then I will reference this line, and then I should be able to find the center of the hole. Click on 7.5, close. I will cut the pocket to 5 millimeter. Yeah, why not? Now I'm going to make a second cut. Sketch, create. Okay, I create a reference. Make a second circle. Let's make it a little bit bigger than the cap. 40. Okay, and then I will cut it down for 0.6 would be enough. Okay, now we have a pocket for the cap. Next, I'm going to extrude the visor. Do this by clicking on this plane. Okay, I will reference the geometry. Sometimes it's very difficult to click. It doesn't matter. I click on this line. Alright, so I will click on this, trace the line. If I do this in AutoX Inventor, it's gonna be just one click. I don't have to retrace all the line like this. Let me turn off the point clouds. Okay, so I will mirror all the lines to the other side. What I do is I will delete all of the construction line first, and I will select all the lines, click on mirror, click on the axis. Now I should have all the lines. Okay, next I'm going to pad command extrude it to 35 millimeter. Click on OK. Next I'm going to chamfer this edge and this edge. 30, 35, 35 cannot do, 30, 33. Okay, 33 is fine. The point cloud is touching the surface of the solid. See here, but when I print it with the ABS, it will deform after it's cooling. You probably need to print with the PETG or a PLA for a better result. Okay, let's do some more chamfer in this corner. And 2 for 2 millimeter. Okay, and then I'm going to make another chamfer here on this edge. 1, 2. Click on chamfer. Let's try 3 millimeter. Cannot do. 2.4. Right? That's weird. It should do, right? 2.9. Can I do 3? 3 cannot do. Only can do 2.95. Yeah, it's quite strange. It should be able to do this. Okay, next I'm going to make a base for printing. Click on this plane. Click on sketch. Create external geometry. 1, 2, 3. Okay, I only need the 3 here. And then I'm going to trace the line. Okay, the last one. Okay, next I'm going to offset this line. For that, I'm going to delete the projected line first. So I don't want to select it. Click on delete. Delete. Yeah, I think they have a problem with the selection. Doesn't matter. Okay, I select all the lines I'm going to offset this line to 3 millimeters, and then I'm going to delete the unused line. Then I'm going to connect to closable files. I should have a closable files, right? And next I'm going to mirror this to the other side. Okay, let me close this. I'm going to extrude the sketch reverse 1 millimeter, so it doesn't have to be thick. About 1 millimeter is enough. Click on OK. Next I'm going to fillet all the edge here. Okay, this will be the face that's going down to the print bed. Click on 4 corners. Click on fillet. Let's try 2 millimeter. Okay, that's enough. Okay, next you can export this one. Click on your last function. Click on Files, Export to STL files. You can send it to the slicer. Okay, so here, gonna face this down, slice it. So it's the same. Either you draw it from the inventor or from the FreeCAD, you get the same result. But with the FreeCAD, I can feel that it's take longer time. I mean, for me, I can finish this part in a quarter of the time that I spend on the FreeCAD with the Autodesk Inventor. But it's free, and I'm just learning this software. It's my 5th or 6th project, and if it's just a single part, not a multi-part in the assembly, I think the FreeCAD is fine for working with the reverse engineering from a 3D scan. Here's from the Autodesk Inventor. Autodesk Inventor is faster and easier to create this model for me, and the FreeCAD is a bit more difficult, but it gives the same result. I highly recommend if you have a 3D scanner and you don't want to invest in a more expensive software just for the hobby or making a simple part like this. So I highly recommend FreeCAD. You can reverse, you can creating a model around your 3D scan. Alright, okay, thanks you guys for watching. See you in the next video.